Okay, hello everyone. Thank you so much for following our lectures here. And today I will be discussing with you lecture number 11 about the properties of fluids. So let's see what we have today. So first thing you have to understand, what does the word fluid mean? The word fluid usually means a gas or a liquid. So for example, water is a fluid, hydrogen, oxygen, air, all these are called fluids. So the first thing I want you to know here is what we define as the buoyancy or the buoyant force. So the buoyancy is the ability of a fluid, gas or a liquid to exert an upward force on an object immersed in it. This is what we call the buoyancy. So buoyancy basically means that you can, if you try to carry your friend now, it would be difficult, especially if your friend is heavy, it would be difficult to carry him. But if you try to carry the same person inside the swimming pool, it will be way easier. Now, why is that? Because the water helps you with an upward force, and this force helps you to carry this person. So then what is the buoyancy or the buoyant force? It's an upward force that acts on any object that is immersed in a fluid. Now, what does the word immersed mean? Immersed means that it is totally inserted or partially inserted inside a fluid. So whenever you have any object that is immersed inside a fluid, there will be an upward force. There will be an external force that comes from the fluid, and this force helps you to carry the object upwards. Now there is one of the great scientists, his name is Archimedes, and he told us how to calculate this force, how to calculate this buoyancy force. Now first thing in your notebooks, I want you please to write this equation. It says that the buoyant force Fb equals to rho, which is the density, multiplied by g, which is the acceleration due to gravity, multiplied by v, which is the volume. So let's see exactly what does that mean. Now rho is the density of what? It is the density of the fluid. Like for example, if you insert an object inside a cup of water, then this would be the density of the water. Now what about g? G is the acceleration due to gravity, which is 9.8 meters per second squared. And what is V? V is the volume of the object immersed inside the fluid, or it is the volume of the fluid displaced. Both are okay because the object will displace, will remove a certain amount of the water or of the fluid exactly equal to the volume of the object. So please try to memorize this equation. It says Fb equal to rho multiplied by g multiplied by v. So let's see what Archimedes told us. He said that the buoyant force on an object is equal to the weight of the fluid displaced by the object. The buoyant force on an object is equal to the weight of the fluid displaced by the object. So what does that mean? Let's say that I have this cup of water, and let's say that it is fully filled with the water. Now if I immerse a piece of steel inside the water, what will happen is some of the water will be removed, will be displaced. So let's say that I have another cup here, and I was able to collect this water that had been displaced. Now, if I take this water that had been displaced and find its weight, then the weight of the water will exactly equal to the buoyant force. So let me repeat this one more time. So let's say that I have this cup of water, and then I fill it all the way to the top here. And then if I put a piece of steel inside the water, what will happen is, of course, the water will overflow, right? So let's say that this water overflowed and I was able to collect the water that had been removed or had been displaced. Now, if I do this and find the weight of the water that had been displaced, then the weight must equal to this buoyant force. So then I can also find another definition of the buoyant force that says that the buoyant force equals to the fluid weight. Not this fluid, but the fluid that had been displaced, and it's equal to m multiplied by g. Okay, so now we need to know what's the buoyant force, which is the upward force acts on any object that is immersed in a fluid. I have to know what's Archimedes' principle that tells us how to calculate this buoyant force, and again is equal to the weight of the fluid displaced. And finally, we have to know that this buoyant force equal to this equation, which is the weight of the fluid displaced. Okay, now look at these two pictures. Now in this picture, I have two objects. One of them is made up of steel, the other one is made up of wood. Now assume that these two fluids are water, so I have exactly the same fluid here. And let's say that the volume of the steel exactly equals to the volume of the wood. So two different materials, but they are both having exactly the same volume. And let's assume that both of them are totally immersed inside this water. So my question to you is, which one should have a higher buoyant force? Is it the wood or is it the steel? Which one of these two objects should have a higher buoyant force? So do you guys know the answer? So is it the steel that should have a higher buoyant force, or is it the wood, or if the buoyant force is exactly equal to each other? So I give you a few seconds to think about this question. And if you say the steel has a higher buoyant force, then your answer is not correct. Also, if you say that the wood has a higher buoyant force, also your answer is not correct. Now, the buoyant force for the wood and for the steel is exactly the same. Now, you may be surprised. How come they are exactly the same? Now, remember I told you that both blocks are totally immersed inside the fluid. Now, why it's exactly the same? Now, look at this equation. The buoyant force depends on what? It depends on the density. It depends on the acceleration due to gravity, and it depends on the volume. But density of what? The density of the water. And remember that the water here and there has the same density, exactly the same density. What about G? G is also the same. It's 9.8 meters per second squared. Now what about the volume? Remember that the steel and the wood both have exactly the same volume, so they will both remove exactly the same amount of water, which means that the amount of water displaced is exactly the same. So that tells us that the buoyant force on the steel and on the wood is the same. So if the buoyant force, which is the upward force, is the same, then why then steel sinks but wood floats? Now here's the thing. Now which one has a bigger weight, the steel or the wood? If they both have the same volume, then the steel must have a bigger weight than the wood. So in case of the steel, the weight is bigger than the buoyant force. But for the wood, the weight is equals to the buoyant force. So that's why the wood will float, but the steel will sink. Okay, so this will take us to the second equation here that I also want you please to know very well. It says the density. The density equals to the mass over volume. So if you want to find the density of any object, then divide its mass by its volume. Now the mass is in kilograms and the volume is in meter cubed. So the density is in kilograms per meter cubed. Okay. And now we have just mentioned that steel sinks. Steel sinks. So why then ships made up of steel do not sink? Now you can see this very big ship, and this ship is made up of steel, but it does not sink. It can still float on the water. So why is that? Now the reason is because of the shape of the ship. See, this shape is not only steel. It has steel, but it has also air inside. So the combined density, which is steel plus air, is less than the density of the water. That's why this ship can float. It will not sink in the water. So here you can see why a small solid steel block sinks, but several ton steel ship floats on water. So of course, if I have a small piece of steel, if I drop it in a cup of water, it will sink. Because it's solid steel, everything inside is steel. But for those big ships, they have steel and also they have air inside, so the total density is less than the density of the water. That's why it floats. Okay, now we go to the next equation, which is called the pressure. And the pressure equation tells us that the pressure equals to the force divided by the area. Pressure equal to the force divided by the area. And please, I also want you to write this in your notebook. This is a very important equation that says pressure equal to the force divided by the area. Now, who can tell me what is the unit to measure force? Exactly, so it's newtons. What about the area? It's meters squared. Very good. So the pressure is measured in units called Newton per meter squared, or sometimes we call this Pascal. Pascal, Pascal. So the Pascal, 1 Pascal equals to 1 Newton divided by 1 meter squared. So that's how we can measure the pressure equal to the force divided by the area. Okay, now let me ask you this question. Now sometimes we see ladies, women, they like to wear those high heels. You know the high heels, those very thin shoes. So if a lady is wearing a high heel and she is walking on a floor, like a wooden floor, now do you think she will put a high pressure or a low pressure on the floor? The question again is, a lady is wearing a very thin shoes. Now, if she walks on a floor, does she put a high pressure or a low pressure on the floor? Yeah, exactly. So the pressure will be high. Now, why is that? Because the area is small. Remember, the area of the shoes is small. That's why the pressure is high. Now, there is another example, like if you guys like to watch the people who like to do those magic tricks, and you can see a person who gets a board filled up with nails, and then he or she sleeps on those nails, and the nails do not go through his or her body. And you guys know, like if you sleep on a large board filled up with nails, why the nails do not go or penetrate through your body? Yes, exactly. This is because the area is large, and because the area is large, the pressure is small, so the nails will not penetrate through your body. But if you ask those people who do magic tricks to sleep on only one nail, they cannot. Of course they cannot. Why? Because the area is very small, the pressure so the pressure is high, so the nail may penetrate through their body. Okay, now the next topic is very interesting, and it's called the Pascal's Principle. It's called Pascal's Principle, and this is one of the very important topics that you probably must see in your major exam. Like every exam we see a question about Pascal's Principle. So please make sure to understand what is the Pascal's Principle. The Pascal's Principle tells us that the pressure applied to a fluid is transmitted throughout the fluid. So again, what does the word fluid mean? It means a gas or a liquid. So Pascal, he is one of the great scientists. He told us that if you have a fluid like this, like oil or any other fluid, if you apply a pressure on that fluid, what will happen is this pressure must be transferred all the way to the other end of the fluid. So in other words, the pressure input must equal to the pressure output. or P1 equals to P2. So what does that mean? It means that if I have this let's say a container that contains a fluid, let's say I fill this with oil, then I apply a pressure here P1, then I get a pressure there P2, then P1 must equal to P2. Okay, so who cares about this? Who cares about P1 equals to P2? Let me show you why this is so important. Now, we say pressure M equals to the pressure out. Now, if you remember in one of the last slides, I told you that pressure equals to the force divided by the area. So the pressure N equals to the input force divided by the input area. And the pressure out equals to the output force divided by the output area. Okay, so let's see. Input force over the input area equals to the output force equals to the output area. Okay, then this is good again. But why this is important? Now let me show you. Now let's say that we discussed a figure like this, and let's say that the input area is 1 and the output area is 5. So this is 1 meter squared and this is 5 meters squared. And the input force is 100. So you put here 100, you put here 1, and you put here 5. So again, 100, 1, and 5. So what would be the output force? So in this case, the output force would equal to 5 multiplied by 100 divided by 1, that would be 500. Oh wow, this is amazing. So it means that I put a force equals to 100 newtons, but I get a force equals to 500 newtons. Is this amazing? So you put a small force and you get a large force. That's why Pascal's principle is amazing, because you can carry a heavy object by putting a small force. If you have ever noticed when you go to the dentist that if you sit on the dentist chair, the dentist can lift you up and down, and he can or she can move you on the with the chair with a very small press with the dentist feet. Now, why is that? Again, it's because of the Pascal's principle. The dentist apply a small force and he can get a large force. Now the same thing happens if you go to a mechanic to check your car and they put your car on one of those hydraulic lifts. Now this hydraulic lift contains again a fluid inside it, and the mechanic applies just a small force and he can get a large force. So remember that what Pascal's principle all about, that the pressure applied to a fluid is totally transferred through this fluid. Now also, if you think about it, when you drive a car, now can you imagine that this big car can be stopped with the brakes, and with the brakes you apply only a very small force, but you can stop this very big SUV or very big car. Now why you can do that? Again, it's because of the Pascal's principle. You apply a small force on the brakes, it's a small force on a small area, you get a large force on a larger area. Now, of course, if you try to stop this car from outside, you cannot. But from inside with the brakes, with the application of Pascal's principle, you can stop this big truck or big car. Okay, now next topic is about the Bernoulli's principle, and let's see what does the Bernoulli's principle say. Now, the Bernoulli's principle says that the fluid velocity increases when the flow of the fluid restricted, or as the fluid velocity increases, the pressure exerted by that fluid decreases. Okay, so what does Bernoulli told us? He says that if you have a fluid and this fluid moves fast, then the pressure of this fluid becomes less. So what does that mean? It means that if you have air and this air is moving very fast, then the pressure becomes less. if the fluid moves fast, then the pressure becomes less. Now I want you to imagine this. I want you to imagine that you are standing on a train station waiting for a train. And when the train moves fast in front of you, what will happen is the air that is attached to this train will also be dragged with the train. Drag means the air will be pulled with the train. So what will happen is the air that is attached to the train will move fast. So the pressure near the train becomes small. And the pressure on you becomes higher than the pressure near the train. So what will happen is you will be pushed towards the train. You see the idea? That's why it's not advised to stand very close to the train while it approaches the station, because you could be pulled towards the train because of the difference in pressure. You guys may also feel this very well if you drive a car on a highway near a big truck. Now when the truck moves beside you, again, if the truck moves fast, then what happens is it will drag the air. It will make the air that is attached to the truck moves faster, then the pressure becomes smaller, and then your car will start to move towards the truck. Have you guys ever noticed this? This is called the Bernoulli's principle. So you have lots of application about the Bernoulli's principle. Now I want you to check this figure. This figure is important, and it shows you how we can mix water with chemical to spray a garden. So here, what you can see this sprayer. It contains a chemical inside it, and I want to mix this chemical with water in order to spray a garden. So let's say that you have a garden, you want to spray it with this chemical, but you want to dilute this chemical by mixing it with some water. So what happened is I allow the water stream to move through this hose. Now you can see here the radius of the pipe is smaller here than there. So what happened is if I allow the water to move through, then the water will move fast. Okay, now when the water moves fast, so what will happen to the pressure? Then the pressure becomes small, because that's what Bernoulli told us. If the water moves fast, then the pressure here becomes smaller. So what happens is the pressure on the fluid becomes larger than this pressure. So what happens is the chemical will go up and mix with this water stream. Then it will spray the garden. Now the same thing happens when you spray yourself with a perfume. Then the same thing. You press on the sprayer, and then what you do is you allow the air to move fast. And when the air moves fast, so what happens is the pressure on the perfume becomes larger than this pressure, and the perfume moves up, it mixes with the air here, then it sprays you. Okay, so this is the first thing that Bernoulli told us, that if a liquid moves fast, then the pressure becomes smaller. Now also he told us if you restrict the motion of a fluid, it moves faster. So what does that mean? It means that, let's say, look at this picture. Now you can see the size of the pipe here is smaller than there, right? The size here is smaller than there, and it's smaller. Why? And because it's smaller, then the liquid moves faster at this part than that part. So the velocity of the fluid will move faster if you restrict the motion. So if you make the hose smaller, then the fluid moves at a higher velocity. Okay, now the next thing we talk about here is called the viscosity. And what's a viscosity is? Viscosity is the resistance of a fluid to flow. Viscosity is the resistance of a fluid to flow. Now, do you guys remember when we talked about liquids? We said that liquids move, and their motion is in the form of a sliding motion. So I told you that you can imagine a fluid as made up of layers. Like if you can imagine the cup of water that you have now is made up of layers. And if you drop this cup of water, what will happen is those layers will start sliding over each other. They will start sliding. So if they slide fast, then I say the viscosity is low. And if they slide slow, then I say the viscosity is high. So let me tell you, what does viscosity then mean? Viscosity means that if you have two cups, one filled with water, the other one filled with honey, and you drop both of them, so which one shall move faster? Now, of course, the water will move faster because water is less viscous than the honey. Water is less viscous than the honey, so the water will move faster than the honey. Now look at this delicious picture. I see maybe how many pancakes here. Wow, this looks very delicious. And we have this maple syrup, and of course this maple syrup has a higher viscosity than the water, right? Why? Because it moves faster. So it moves slower, sorry. So the viscosity means what? Means the resistance of the fluid particles to move. Because I told you that the fluid is made up of layers, and as these layers, as the higher resistance these layers have, the higher viscosity, and the lower resistance is the lower viscosity. So now we will just stop talking for about 2 minutes. If you guys want to pick up a cup of water or so, I will be waiting for you here. We'll come back soon. So don't go anywhere. I will be around. Just you can take a break, and then we will complete this lecture very soon. So as you guys know, if you have any questions, you can always send emails or you can ask questions. Again, if I say to write anything, you need to write down the equation in your notebook, and would be more than happy to answer any questions anytime. Okay, so I hope you guys are back by now, and now I'm starting the new lecture, which is lecture number 11. It talks about the behavior of gases. So far I talked to you about the fluids, and we learned about fluids. We said that a fluid could be a gas or a liquid. We have learned about the different states of matter. We said that we have the solid state, liquid state, gas state, and we also learn about the plasma. We know the difference between these states in terms of the characteristics. We said that talked about the particles' motion and so on. Now we need to learn about how gases behave. And just before we start, we should understand that in the behavior of gases, we are learning about three things, absolutely three things. One of them is called the volume, the second one is called the pressure, and the third one is called the temperature. So when we speak about any gas, you need to learn about these three parameters very well: volume, pressure, and the temperature. So let me discuss with you this nice picture. The picture itself is not important, but let me discuss with you what is this gentleman is doing here. Now, what is he holding here is a weather balloon, and weather balloons are very important tools that we use to understand the meteorology and the conditions of the air layers. And the idea is, if you, for example, running an airport, you have your airplanes that are keep moving up and down in the skies, you need to know the conditions of the air. Otherwise, the flying will not be very safe. So all the time, airports are sending those air balloons to understand the meteorology, and like they want to know about the temperature, the pressure, the wind speed, the wind direction, the humidity of the different air layers. So they fill this balloon with helium, and as we know that helium is lighter than air. So if I let this balloon go, so it moves up in the atmosphere. And then they attach with this balloon some equipment and that are able to measure the meteorological parameters. So as the balloon moves up, then these instruments will start to collect data about the conditions of the atmosphere. But as I told you before, as you move up in the atmosphere, then the pressure becomes less, basically because you have less air above your head. So as you move up, then the pressure becomes less, and the pressure inside the balloon becomes higher than the pressure outside the balloon. So what happens is this balloon starts to expand. Now, do you notice this? That as the pressure outside becomes less, then the volume becomes bigger. The pressure less, then the volume becomes bigger. And this balloon keeps moving up, keeps expanding, and at a certain point, it just explodes, and then the equipment falls down, and then we can, with a GPS, we can locate those equipment and collect them, and then we can retrieve the data and know about the conditions of the atmosphere. Okay, but the most important thing here is what we have mentioned about the relation between the pressure and the volume. Again, one of the very great scientists, his name is Boyle, told us about the relation between the pressure and the volume of a gas. So let's see what did Boyle told us. So he states that for a fixed amount of a gas at a constant temperature, the pressure and the volume are inversely related. Okay, so now let's talk about this. It's called inversely related. So what does inversely related mean? So inversely means if one of the parameters increases, then the other one decreases. If one increases, the other one decreases. So Boyle told us that we have three parameters. We have the pressure, we have the volume, and we have the temperature. But he said, be careful. I want you to keep the temperature constant. I want to keep the temperature constant, and I also want you to keep the amount of the gas constant. So don't add more, or don't add more gas, or then don't take any gas off your container. So if these two conditions are satisfied, then the pressure and the volume will be inversely proportional. It means that if you increase the pressure, the volume decreases. If you decrease the pressure, the volume increases. So maybe you guys know this sign. This sign is called the proportionality sign. It says that the volume is inversely proportional here with the pressure. Now please write this down in your notebook. It says that P1 V1 equals to P2 V2. P1 V1 equals to P2 V2. So this is the pressure 1, volume 1 equal to pressure 2, volume 2. Now look at this picture. It contains this piston, and you can see here, if I apply a pressure of 100 kilopascal, remember the pascal is a unit to measure the pressure, so the kilopascals means 1000 pascals. So if I do this, then the volume is 10 liters. So what if I increase the pressure to 200 kilopascals? Then the volume becomes less. It becomes only 5 liters. Can you see that? So if you increase the pressure to 400 kilopascals, then the volume becomes 2.5 liters and so on. So you can see here, as you increase the pressure, the volume decreases. Now, this graph is also important. You must know this graph very well, and when you see it, you must know it. This graph relates to the Boyle's law. So the graph says that if you have volume in liters as y-axis and you have pressure in kilopascal as x-axis, so you will get this graph. Now this graph means that the relation between them is inversely proportional. So as you can see here, if the pressure is 100 kilopascals, the volume is 10 liters. If the pressure becomes 200 pascals, then the volume becomes 5 liters. If the pressure is 400 kilopascals, then the volume becomes 2.5 liters and so on. Okay, so I hope you guys now know what's Boyle's law. P1 V1 equals to P2 V2. Now let's speak about the next law, which gives us the relation between the volume and the temperature. Okay, so as I told you a few minutes ago, that we have three parameters. We have pressure, we have volume, and also we have temperature. So in Boyle's law, we learned the relation between the pressure and the volume, but remember that the temperature must be constant. Here, we are learning the relation between the volume and the temperature, but the pressure here must be constant. Okay, so now if you remember, I talked to you before about the hot air balloons and how those balloons can move up and move down. I will just remind you that if you want the hot air balloon to move up, all what you need to do is you need to heat the air inside. Now what happens when you heat the air? When you heat the air, then air particles start to move away from each other. And when they move away from each other, there will be bigger spaces between them. So the density of the air inside the balloon becomes less than the density of the air outside the balloon. So what happens is the balloon becomes lighter and then the hot air balloon starts to move up. So what if I want the hot air balloon to move down? Then in this case, I cool down the air. I decrease the temperature of the air. So then what happens is the air particles start to get closer to each other, and when they get closer, then the air becomes more dense. More dense than what? More dense than the air outside the balloon. So the balloon becomes heavier, and then it starts to move down. So look at this. Now what I did, if I heat up, then the volume increases. If I cool down, then the volume of the air decreases. So what is this? This is what we call the Charles law. So Charles law gives us the relation between the volume and the temperature. So Charles told us that for a fixed amount of gas at a constant pressure, the volume and the temperature are directly related. So you see here, the Charles give us the relation between the volume and the temperature. But again, you must be careful here that this is only true if the pressure is constant and if there is a fixed amount of gas. So it means that you cannot add up gas, you cannot remove gas. The amount of the gas is fixed. And of course the pressure must be constant. So in this case, the volume will be directly proportional with the temperature. So this is V1 over T1 equals to V2 over T2. So please write this down in your notebook. And if you have your pen, especially if you have a red pen, that would be very nice, because I will tell you something very important here. Very important, you have to be very careful about it. Now this temperature in the equation must be in Kelvin, not in Celsius. Now do you guys remember the relation between Kelvin and Celsius? Yes, very good. Yes, exactly. The Kelvin equals to Celsius plus 273. So this temperature that I use here must be Kelvin. So if someone asks you a question and you want to use Charles' law, then please make sure to use this temperature in Kelvin by adding 273. Like let's say you have been told that the temperature is 23 degrees Celsius, so your answer must be 23 plus 273 to give you the right answer. If you use Celsius, it would be wrong. Okay, now let's discuss this graph, and this graph gives us the relation between the volume and the temperature. Now look at this. Now here I have three different gases: gas A, gas B, and gas C. Now, these are any three different gases. They could be hydrogen, oxygen, nitrogen, anything, right? Now, you will notice that it doesn't matter what is the gas or what kind of a gas we are talking about, it's always directly proportional. If I increase the temperature in Kelvin, the volume must increase, okay, no matter which gas we are using. But you will notice something very interesting here in this graph. You will notice that part of the line is solid, the other part is dashed. Can you see this part is dashed? Now why this part is dashed? Now these dashed parts is what we call the extrapolation. And what does extrapolation here? It means that this part of the graph was not done by an experiment. It was, what we just did is we just got a pen and a ruler, and then we extended those lines by hand manually without doing an experiment. So again, what does that mean? It means that the solid part of the graph was done using an experiment. So I got a gas, and then what I did is I heated up the gas and I measured the volume and the temperature. And I found the relation between the volume and the temperature by using an experiment. But for this part, we did not do an experiment. And why is that? Because the temperature here is very low. 150 Kelvin is low. And you may think, oh no, this is 150 Kelvin. That's not no, that is not low. No, it is, because remember, Kelvin equals to Celsius plus 273. So to find the Celsius, it will be 150 minus 273. That is a low temperature. That would be in a negative temperature, right? So it's difficult to do this to reach this temperature in the lab. That's why we just extend this part, and we call this extrapolation. Now, this is very interesting because if you extend these three lines, you will notice that you will reach this point, which is 0 Kelvin. Now, what does that mean? It means that if the temperature is 0, the volume becomes 0. And what does that mean? This means that at 0 Kelvin, there will be no volume. And what does it mean, no volume? It means that there will be no matter at all. Now, it is true. We don't know. We don't know because no one is able to reach 0 Kelvin. We can reach very close to 0 Kelvin. Like scientists are working on trying to cool down substances, but no one is able to reach 0 Kelvin. So what will happen at 0 Kelvin? Will the matter, will the substance disappear? Again, we don't know. This is a very big question in science. Now the other thing is, if you guys remember, when I taught you about temperature, we said that the temperature represents the kinetic energy of the particles. I told you that if you make a cup of tea and you and you heat it up, then particles move faster and faster and faster, right? So the temperature represents the kinetic energy of the particles. So when I have 0 Kelvin, it means that I have zero kinetic energy of the particles. It means that the particle will stop moving. Again, this is very interesting. So if you remember when we talked about solids, liquid, and gases, we said that no matter what state of matter we talk about, then particles are still moving. But here we say that at 0 Kelvin, particle will stop to move. Now, is this true? Again, we don't know because no one was able to reach 0 Kelvin ever. Again, this is a very big question that needs to be discussed and investigated in science. So that takes us to this definition, which is called the absolute zero. And what is the absolute zero? Is the temperature at which the particles of a matter come to a complete stop. And what the 0 Kelvin is minus 273 Celsius. So the 0 Kelvin is what we call the absolute zero, and this is the temperature at which particles particles of a matter would come to a complete stop. Okay, so this will conclude this lecture. I hope you guys got this information, and like more questions will be posted online, so we will be able to practice all these questions, inshallah, very soon. So thank you so much for listening, and I will see you in more lectures soon, inshallah. And please pay attention to any announcement that you may receive. Thank you. Bye.